panel discussion, I want to invite the moderator to the stage first. Ms. Zhu Liangwei, please come onto the stage to moderate the panel discussion. She is the Deputy Head of the International Cooperation Department of China Petroleum and Chemical Industry Federation. Also, I would like to invite our panelists to the stage, Mr. Lai Chunbo, Vice General Manager of Shanghai Research Institute of Chemical Industry Corporation Limited, Liu Guosheng, Research Fellow of Shanghai Institute of Organic Chemistry, Chinese Academy of Sciences, Shi Bingfen, Professor at Zhejiang University, and Grace Xu, Principal PGM Analysis Marketing with Anglo America, and Lu Wenzhi, General Manager of Shanghai PJCHEM. Please come onto the stage.
Hello, everyone. I am from China Petroleum and Chemical Industry Federation. I'm Zhu Liangwei, and I'm in charge of the international cooperation and also the work at the Hydrogen Commission. So Anglo-American is a core member of our federation. So it is a great pleasure to sit here with all the experts to talk about the scientific breakthroughs of green chemistry. Well, we all know that chemical industry is one of the pillars to the economy of many countries, and green chemical has become a emerging area for the countries to cope with the challenges in the carbon neutral and carbon peak. So you can go by Mr. Huang.
就已经成为了全球化工行业产值最大的区域，并且根据去年的统计，根据 CIFIC 的统计啊，不是我们的统计，这个 CIFIC 的统计，我们按照它的统计，中国的化工的产值已经超过了欧洲和美国的产值之和，所以我们中国的化工行业在全球，不管是生产还是使用，还是产业链上的供应，都是位于前列的。然后对于我们这个绿色化工来说，我们中国市场上在产在用的化工产品大概有超过5万种。对于这些5万多种化工产品来说，目前随着产业结构的升级以及对这个技术水平的提升，我们大家也能感觉到啊，整个社会对我们化学物质的，包括环境风险、安全风险、健康风险的关注度越来越提升。但是呢，总体来说，我们还没有开展非常系统的关于化学物质的这个整体的系统的风险评估以及管控，所以我们化工行业距离构建起完备系统的绿色化工还有一定的差距。所以呢，我们今天和参与讨论的各位专家都是绿色化工科技创新前沿的专家，很高兴和大家讨论一下对于我们化工行业如何构建我们绿色化工发展的这么一个趋势，尤其是贵金属在里边会发挥什么样的作用。首先呢，我想先请问一下我们这个上海化工研究院的副总经理赖总，我们大家都知道啊，我们上海化工研究院在聚烯烃催化剂，包括这个很多新的材料都处于这个创新的前沿，尤其是在化学物质的检测领域。那么我们说绿色化工，那您认为绿色化工的评价标准是什么呢？
谢谢朱主任啊，那我也谈一下我的一个分享，关于绿色
chemistry. Well, this is a buzzword already, and people talk about its 12 principles before. Well, I will talk about my own understanding. Well, the first thing, we need to solve the cost problem. Well, just now we heard the carbonylation reaction. I actually work in this area. So the key in carbonylation is the OXO reaction. So we need to really manage the reaction at the atom level. The second thing is about carbon emission and the utilization rate of carbon. So coal industry has a lot of carbon, but not enough hydrogen. So when the chemical reaction happens, in order to get the hydrogen from the air, they need to convert carbon monoxide to carbon dioxide, which is a very low efficient reaction. But if we are able to achieve the carbonylation process, then the whole efficiency will be improved. And also, if we are able to combine the coal industry with the green chemistry, then we can cancel out its impact to the environment. And the third thing is, well, sustainability and environment is crucial. So in our industry, we say there is a environment element. It's basically the chemical waste minus divided by the chemical volume. Well, in the past, this ratio is pretty high, and also the equipment is not ideal. So E times Q is a big issue at the moment, environmental-wise. The fourth thing, we talked about the chemistry, and we should also move on to the production of the chemical products. For example, how to best utilize the reaction, the heat coming from the reaction, especially the carbonylation reaction. So every metric ton of the products would need 1 ton of the energies, but as we develop this whole system, then the energy conservation will be improved. So even we can drastically reduce the energy use to 0.02, and also to better manage the reaction, we can use the top-notch technologies like the green portal improvements. Today, the key topic is a precious metal, and we have to say the catalytic effect of the
这个催化剂只要40 ppm 的钯催化剂就够了。那么我们烯烃氢钾氢化这里做得好的话，我们也现在也可以用到50到100 ppm 的，就是一个老催化剂，那实现很高效的一个应用。那么我们像汤基合成醋酸也好，或者是那些好的烯烃氢钾催化剂，我们可以用10来年的一个寿命，甚至一直不更换。这个就是反应是非常的一个高效的。那么除了这一点以外，我想最重要的还有一个这个全生命周期的一个考量，就全生命周期一个产品从它出生到最后可能呢，那就是废弃物。那么我想这个也是需要考量的一个因素。那么我想这边分享的就这几点嘛。好，谢谢周主任。
好，谢谢赖总。总结一下，就是赖总做了一个非常好的这个标准总结。第一个就是这个原子经济性，第二个低排放，第三个呢就是低的污染物排放，也就是对环境有较小的影响。第四个呢，高效低能耗的过程工艺非常感谢。下一个问题呢，我们想请这个刚才我们做发言的中科院的这个丁云杰丁研究员来回答。您是在这个绿色化工科技创新，刚才提了非常多的这个创新，尤其是我们石油化工行业印象都非常深刻尤其是刚才在底下交流吉尔安，基本上国产的这些项目都是我们这个中科院我们这个丁老师这边在做的然后您看目前如果说绿色化工的科技创新的趋势，您想如何阐述这个趋势？
我个人认为就是一个绿色化工的过程，不但要从你的目标产物的活性、显热性，主要是显热性的提高。就是我本来有100个分子，我能够90个或者99个分子都到我的目标。
5% out of all the atoms can be selected, then it will be highly efficient. The second thing is it should be energy efficient. The third thing people haven't given it enough attention is how to use the reaction heat. Well, some reaction is in the 100 degrees Celsius or 200 degrees Celsius environment. So in this reaction, the heat is not used to the ultimate. If we are able to improve the reaction in the crystalline phase and in other phases, maybe we can utilize those heat and make it into a coal, for example. It's just like the media is different. It used to be hot, water, but later, it can be made into other forms. If we are able to utilize this heat from the reaction, well, it can go a long way for the green chemistry. For example, the heat from the reaction, you can use it as a thermal power to generate electricity. So the reaction itself generates heat. Why not utilize it, take it as taking it as a thermal power? So far, a lot of such heat went to waste. So if we are able to take advantage of the reaction heat, then many low-grade heat can be put into a better use and can generate power accordingly. Well, thank you very much, Mr. Ding. To green chemistry, well, for many the producers, our biggest concern is how to improve the conversion rate, how to improve the efficiency, how to take the most products out of the chemical reaction. And the second is how to achieve a better energy efficiency, reduce the energy consumption, reduce the emission at the same time. So this is a very valuable insights. And this next question goes to Huang Hanmin. In the chemical industry, there are many challenges. We all know that last month, there was just ended the second plastic convention in the UN. And in April, there was just completed the negotiation of the plastic particle. And we're also facing Basel Convention and the Stockholm Convention. All these are challenges to the chemical industries. Facing these challenges, can we overcome all these difficulties with technology? Well, I want to approach this question from three aspects. First of all, in the future, there will be a more stringent standards and criteria in inspections and examination. For us, maybe we can improve the reaction efficiency, reduce the impurities, reduce the pollution. I think this is one way we can approach this. The second thing is just like Mr. Lai mentioned, we should work on this crystalline phase. We need to redesign its whole process from scratch.
反应方法，比如说刚才我们提到这个苯乙酸，苯乙酸是制备青霉素的一个重要中间体。那么以往的路线是甲苯先氯化，那这里面会带进氯，那么它再进一步跟氰化钠反应，这会带进这个氢根离子。如果你搞不好的话，比如说你有一点点氰化钠的残留，那么是致命的。 假如我们现在换一个步骤去干，我们直接从甲苯出发，没有这个氯，没有这个氢根离子，那么这样从源头上就杜绝了这些杂质的产生，那这样是一个非常大的一个改进。那这样的话，你就不会有这个问题产生。那么另外第三个层面就是说，很多分子我们是不是可以创造新的分子？那么这个新的我们分子的作用主要是体现在它的功能上面。 那么你创造一个类似的分子，这个分子更简单。那么如果它有类似的功能的话，那么就可以避免这些新的以往的老工艺或老的化物所带来的不可避免的在这个路线带来的这些杂质的影响。我想这是一个非常重要的一点。比如说这个氟利昂也好，或者是我们对苯二甲酸，它对苯二甲酸做了个聚酯。 假如我们现在用氟蓝二甲酸代替这个东西的话，那么它的功能可能一样，它的降解性能或者是转化性能可能会更好。那么这样整个分子就改变了这个世界。我们就经常提到的化学里面经常讲分子改变世界，这样创造新的分子、新的功能，赋予它的新的功能的时候，这个时候能够完完全全的、彻底的改变以往的这个落后的产能呢，会所带来的这一系列的负效应。我想就回答这。好，谢谢。
非常感谢黄老师的回答，您这个回答让我们这个行业，我相信给我们非常多的信心。说实话，现在面对我们如此多的这种国际的包括国际公约，包括这些 各种目录啊，大家看到 REACH 目录又增加了新的这个高风险物质的清单。我们行业面临这些挑战，刚才您提到非常非常重要的2个途径，第一个创造新分子，第二个通过新工艺去除有毒有害物质。我们希望将来。
So we hope that in the future, not only do we do basic research and we'll achieve the purposes via either of the 2 pathways you talk about, and I look forward to seeing their industrial applications, such novel approaches being used industrially. China, we have a huge number of petrochemical companies. Maybe in the future, when we are on the bargaining table, say that if your industry is to replace or to remove toxic or hazardous substances, if someone asks us to do it, we can tell them with confidence that we have solutions to address the so-called toxicity or hazard that you propose. Thank you very much. My next question goes to Mr. Liu from Shanghai Puqing Chemical New Materials. So your company is very good in terms of new materials, and in particular in catalyst, you are a little giant with great innovative creativity. We just held Asia Petrochemical and Refining Conference in Yantai. We heard experts from your company talking about MMA, very excellent and impressive presentation. So I just want to ask you, in terms of green chemistry and green chemical innovation, we know that your company is rather flexible and you are very efficient in doing innovation. Can you just talk to us what you have done in terms of green chemical innovation? Thank you. And what results you have achieved by them? Well, many thanks to the moderator for asking this question regarding green chemistry. My company has always been committed to technological innovation, and our products are actually our technology, as well as catalysts that come with our technologies. All of our technologies contain catalysts. So in terms of how catalyst is related to green chemistry, I echo with Mr. Chen. When we do catalyst, the catalyst is actually part of green chemistry because you reduce or you make reaction conditions less demanding, you accelerate the reaction speed. So that in itself is green, but green chemistry contains more than catalyst. You need to consider processes as well as green raw materials as well. But as someone working in catalyst, we can be proudly claiming that we are in the field of green chemistry. Regarding innovation in, say, my company is a it's a privately owned company, and we only have a history of a dozen years. We started from zero, but now we have a number of catalyst-related technologies. It's not easy to do R&D for a small company like us, compared with as large SOEs with abundant resources and financial means. We rely solely on ourselves, and our products are put to the market facing market competition. Regarding how flexible our mechanism can be, of course, different types of companies have different advantages. We have 2 advantages. First is outreach or collaboration. We don't have concerns like the loss of state-owned assets or state-owned assets falling into the wrong hands, like the concerns of state-owned companies. We don't have such concerns. So we can collaborate with research institute. We can do incubation of novel technology even before they have proved their feasibility. Even when technology is not there, when we see a trend or a direction, we can put in some money to invest in to do R&D of a new technology.
一个对这个工业化
We do that.
客户可以应用的这个技术。有时候像我们的这些合作就胆子会比较大，有时候就是一个高校的或者一个这个院所的这个技术，我就让他去研究，但是只要你的技术最后比如说优先这个签约权，我都可以愿意来掏钱来去这个资助这方面的项目。另外的话就是我们在那个对我们来说啊，我们因为是最终的目标，这个技术是对客户来说是优化的一个技术，所以呢，我可能这个技术我可以跟这个很多的这个 科研院所合作，我可以把各方面的这个技术，哪怕有可能他们是竞争的技术，都可以合并到我一个整体的技术里面来，然后我被变成一个客户最优化的技术，我可以跟研究的、跟工程的各方面，在这个小试啊或者在这个中试整个过程中，我可以变成一个综合性最优位的一个技术啊，这是我们这个比较有灵活性的。当然对内的这个灵活性呢，就是我们可以在，对吧？激发内部员工的这个激励机制这方面呢，我们肯定有自己灵活性。比如说，我可以通过这个项目分成啊、股权激励啊，然后呢，可以包括一个项目，如果是到可以公益化，都可以允许员工自己去成立一个相应的公司，引入外部的这个投资的这个力量，都可以，都很灵活啊，这方面。所以这个是从机制方面的来说。如果说从这个绿色化工啊，包括这个贵金属的这个项目这块来说啊，应该来说，目前普建化工的，我看大部分项目都是其实都是用的贵金属的啊，包括一开始的我们的这个甲醇制醋酸，对吧？这个用这个老的体系，包括现在这个疗一新的体系，都是在贵金属。后面的这个梅子乙醇，对吧？前面一步也是用到这个8的这个催化剂，还有我们后面做了这个醋酸制乙醇的这个也是做了中试啊。2种催化剂，其实贵金属和贵金属我们都做了，对吧？前面的这个有铂的催化剂，还有这个新的这个非贵金属的。但贵金属也有它的优势啊，就是它的寿命各方面、稳定性各方面也比较。
They have long life and they have more advantageous properties, and we also have other types, other projects using precious metal such as ethylene method, and Anglo America participated in a lot of the projects I listed, including some of the incubation projects. It reminds me of the topic back in another conference. The first is how to evaluate the value of innovation, and the second is how to do collaboration to achieve innovation. So you talk about pulling together of resources from various parties, supported by incentives and mechanism in order to incentivize more technological innovation as well as further commercialization. I think you can share more of your examples with people in the industry, like if we have time going forward. My next speaker goes to Grace Chu to Anglo America. As we know, Anglo America is a definitive leader in PGM and in particular in catalysts. So the question to you, Grace, how do you leverage the innovative potential of PGMs? How to make them irreplaceable in terms of green chemistry? Many thanks to the moderator. I'm really honored to be invited to the panel discussion. PGM as chemical metals have very unique chemical properties. They allow chemical reaction to happen in a more moderate environment and conditions, and the PGMs are highly efficient and highly selective. PGMs are used extensively in conventional chemical reactions such as oil refinery, PDH, PGA acetate, among others. They have been used for a long time. In terms of how they can be used in green chemistry and in particular innovatively, we think that green chemistry at the end of the day represents technological progress against the backdrop of China's initiative to achieve carbon peak neutrality by 30 and 60 respectively. Petrochemical and chemical industry are one of the 6 most energy intensive industries. So how to achieve, or the industry actually has this inherent call for bringing emissions down. And it is against this backdrop that we have increasingly noticed that more and more research institutes, universities, and companies start to pay more and more attention to chemical processes as well as synthesis using PGMs. And in this process, we have noticed that in terms of green amine, green hydrogen, green ethanol, as well as MMA and electrolyzer liquid, PGM play a very important role in all these areas. A lot of the players in the industry, when they are asked about the applications of PGM in the green chemistry, always have two questions, and we got asked a lot regarding the two questions. The first is about price, as the PGMs are precious metals, so they do not have competitive advantage compared with other types of metal. And second, sometimes we hear that people say that PGMs, the supply is small. How can they meet the tremendous demand that is expectable going forward? From our perspective, as you know, that PGMs are very stable and they have very stable supply system. Why are we saying that? Because around the world in the auto industry, with the market of hundreds of millions of vehicles sold, PGM or platinum has long been supplied to the auto industry as a component of the auto catalyst, a testament to the supply stability. The supply of PGM has two parts, including primary and recycling. Our understanding is that total supply of PGM stands at 630, with primary being 480, and the rest comes from recycling. In other words, recycling accounts for about 24% of the total supply of PGM globally. So we think that in the future, in terms of the technological innovation of green chemistry as a highly efficient and highly selective catalyst, PGMs can be recycled and reused. Such unique property makes them indispensable, and it's not something that we can afford to ignore. Thank you. Thank you very much, Grace. We heard from your answer that Anglo American not only pays attention to the application of PGMs in various markets, but also pays attention to the recycling and reuse of PGM throughout the life cycle of these metals. And Anglo America is developing new technological pathway in order to have better recycling and reuse of PGMs. So we hope that more companies can show your responsibility and operate your business in a more responsible way and participate in green chemistry as a responsible player. Next, I would like to ask Mr. Lai the second question. You talk about evaluation criteria for green chemistry. Actually, for those of us working in the chemical industry, we know that the industry has very wide range of or very scope with a lot of different types of products, which is actually a unique characteristic of the chemicals industry. For this industry, it's rather hard to release, say, energy emissions standards or energy consumption criteria. We face a lot of challenges simply because the sheer size of the industry and the huge variety of the products that this industry offers. So you talk about the evaluation criteria for green chemistry. Can you give us a couple of examples? Definitely. For the chemical industry, if we want to develop green chemistry for a better life, that's a slogan that we always pursue, and is also our mission. So for green chemistry products, they must be environmentally friendly and they must be compatible with the overall ecology. Take the example of CO, from CO, methanol, all the way to acetate. The process is very atomically economical and it's energy saving. And the acetate's purity is good. If the process is good, you manage to make the process good. And then from alcohols to acids, these types of products, from RPH, like RPH that was mentioned by a previous speaker, they all represent products of the chemical industry. They are environmentally friendly and they are energy efficient.
The second is a decomposable material, and this is something we are doing. So we want to achieve the synthetic and anhydride. So this is the final outcome we want to achieve to make the product that I mentioned. So this is one way we can make our products more environmental friendly. And also in the past, for the cooler, well, or the refrigeration, it used to have formaldehyde, but in order to make it less harmful, make it more environmental friendly, we are also canceling the fluorine in the refrigeration. And also the third thing we can approach is that we can make the product more lightweight, for example, to replace the steel using the flat plastic. Also, there are some foaming technologies that can make the materials lighter, and by handling these lighter materials, it can also reduce the energy consumption. So these are the few approaches we are doing to make our products more green. So just now, Mr. Lai have given examples on what are the and how to reduce hazards of
产品本身是可持续性的，并且这些产品的生产过程、生产工艺是低能耗、低排放的。非常感谢给我们行业指明了非常清晰的这个路径。接下来想请这个丁老师呢，刚才您对于这个目前绿色产品的化工科技创新趋势做了介绍，想请您介绍一下对于各类金属，尤其是贵金属，在化工绿色转型过程中可以起到哪些作用？
赖总经理就是说了，这个可降解的材料，这是一个趋势，因为白色污染这个对我们的生活确实造成了很多的不方便的地方，然后对这个地球也是不好的。所以呢，我认为呢，就是在这个生物可降解的材料方面，要从强度，要从那个一定的耐久性这个时效性的来说呢，我认为这个就是丁二醇 BDO 是为一个关键的中间体或者平台化合物，怎么去做这个可降解的手段可能更比 PGI 可能更，因为它太短了，太容易降解了。这个是它从出反应器到那个这个我们的那个塑料袋到用户手里，这个周期就要3个月，你3个月后开始降解了，这个事情怎么去解决它，我也不知道。所以呢，我觉得还是要把这目光放回到这个 BDO 的事情上。那么 BDO 呢，你刚才讲到用渗干来，就是从丁烷这个氧化，最后做到渗干再去做这个呢，最大的问题是一个它的过程不是很绿色。不是很不够，就不够绿色，已经是绿色了，但是不够。第二个呢，它的成本，它的生产过程还是，而现在从成本来说，现在你们面临的最大的问题就是有那个缺钱法制备的这个材料制造的 BDO 比你价格要低。但是我们作为一个科技工作者，我们也要开发比缺钱法更便宜、更好的。那么我们最近呢，做了一些工作呢，发现一个非常好的反应。我们也做了一些很多的工作，这实际上这个是一个金相催化反应的体系。这个催化剂反应体系呢，也做了几十年了，但是它一直没有解决好这个催化剂的被还原的问题。就是说有2加的8。这个贵金属催化的这个乙炔的熵羰基化，一熵羰基化就变碳碳再加一个醇，它就被酯化，酯化以后就是到了再加氢，那就是 BDO。所以呢，我们呢在这个刚才又讲了，我们就是在做精相催化、多相化的过程中，我们用了催化剂也是8，然后呢，它是解决不了这8的被还原的过程。那我们呢已经解决这个问题了，在我们的多项的这个熵羰基化里面，叫正式的学名叫做烷氧羰基化，对吧？这样一个过程，我们已经发现它 这个8不会被还原，它一直是保持着正二价。正二价，所以呢，这个最核心的问题我们已经攻克了。当然还有一些小问题，我们正在攻克。只要这个攻克呢，我觉得在我的有生之年可能能够看到这个工业化的这个前景。那时候给我们提供更美好、更绿色、更这个生活降解更好的这种日常的这个塑料这样一个。我就讲这些，好吧？
好，谢谢丁老师，我们期待这一天啊。这个从丁老师刚才介绍这案例里边，我们可以看到贵金属啊，包括刚才您讲了8，在这绿色化工这工艺里边有非常至关重要的作用。谢谢。接下来我们想再请问一下这个黄老师，刚才您提了2个非常激动人心的2条路径对于我们这个未来绿色化工转型的这个路径尤其是针对各种挑战的路径。您能不能介绍一下，就是说和产业界合作的，比如说1、2个案例，在符合就某一个刚才您介绍的2条路中间某一个，是不是已经有产业化的这种案例啊？
这个我现在才刚开始跟这个产业界合作，跟企业界合作去做这个中石放大。那么我感觉到要挖掘这个真正的新技术走向电子生产力。我觉得这里面可能企业刚开始要一些比较宽容的接受新技术的这个心态，因为我们这个新技术，比如说甲苯直接反应到苯乙酸，那么别人做的是用氯变跟氰化钠直接做苯乙酸，那么它从这个原料上来比较的话，那虽然我们这个甲苯要便宜些，但是氯变它做得好的话，它跟行会使用的它也做得好，但是这里面它的功耗能耗会高很多。它的碳的足迹，碳中和的碳足迹的它肯定很多，有能量因为在里面消耗碳的。但是，所以说，如果我们现在把这个技术推向市场的话，我们要走一段路，这里面成本可能赶不上这样一个氯变直接做过来的。但是它是牺牲了这个环境的因素，因为你有氯产生，会有氰化钠这些东西产生。所以我觉得，从一个新技术出来到真正去应用，我觉得这里企业要一个心态，比如我们刚开始这个技术是2012年申请专利，那时候用8做催化剂，人家一听说8催化剂很贵，价格很高，他不干了，直接打电话给我，我说你也不要问我了，过10年以后你再找我，因为10年以后我会把这个催化剂变得比较便宜。那么确实我们经过了10年，2022年我们2021年左右，我们把这个催化剂改成镍基催化剂，那么这个催化剂成本就降下来了，降下来的话，这个我们是算了一下，那么这个成本是可以跟那个媲美，而且这个从那个绿色化工来讲，那么它的这个，我相信这个双碳从它这个减碳的角度来讲，碳中和的角度来讲，确实是一个比较好的一个技术。这个技术不光是可以生产苯乙酸，那么一套工艺完成以后，你直接改原料，你可以去做耐普森，会做其他的，比如说这个苯变氟兰酮啊，农药上的一些东西。那我认为，所以说跟我们现在接触的话，我认为。真正的新的反应的突破，可能是在原理上这个突破，但是这个成本上面可能是比不过。但是我们企业家要有这种心态，包容心态，就是我们要看到后面。我经常跟企业的人谈，我说你现在企业做得很好，你想没想到10年以后，或者20年以后、30年以后，你这个企业用你这套技术还能不能存在？我觉得我们要看到后面的问题。我觉得这个是我觉得这个很重要的一点，就是说我们这个企业家。要包容这个科学家的这种创新的意识，让他的创新意识感觉到能够用上去这个盼头。那我们这个科学家就自然这个创新动力，从那个角度来讲，当然我们是我们做教授的肯定是做再原创的技术、再原创的反应，这是我们的使命。但是你如果感觉到更有用，我们做的那么我的经费啊，其他的东西来的玩意会更广。我觉得这个是非常重要的一点。谢谢大家。
谢谢黄老师，非常实在您说的非常实在，确实是这样。因为我们石化联会一直在推动这个基础研究的一些从小试到中试，还有一些是从中试到商业化的一些这个合作，有些是这个和大学合作的，有些是这个国内外企业共享知识产权的合作的，都需要时间比较长的努力。我们在筛选这个技术的 这个合作方的开发方的时候，我们也遇到了刚才您说的这样的问题。但是呢，刚才就是我们说嘛，我们这个行业特点是行业大、产品多、企业也多，所以总是有一些站在创新前沿的企业啊，我们也很愿意在石化联合会的平台上。将来我们有筛选出这样的企业家去做这样的这个产业化前沿的这种技术的创新啊，谢谢。接下来我们想再请问一下这个普景的卢总，就是普景在创新很多产品的创新做了那么多的尝试，请您介绍一下，就是有没有哪些是和铂族金属相关的创新产品助力了传统化工的转型？有没有这样的案例？
刚才其实我介绍了我们那个有很多项目啊，都是会用到这个贵金属的。刚才还有一个方面呢，刚才赖博提醒我，就是我们刚才这个讲到这个降解材料这一块啊，那个聚乙醇酸这一块，那这一块的我再补充讲一下。报告那个丁老师啊，前面报告里面有张图片，就是那个习主席去他是那个21年9月13号在视察那个榆林的那个项目。实际上那边的那个装置的背景就是我们普景授权给这个国家能源集团啊，榆林的，它是一个40万吨的乙醇联产5万吨的聚乙醇酸的这个项目。应该来说，合成器制聚乙醇酸这个项目，我觉得这个结合绿色化工这块，我觉得结合的还是蛮紧的。首先呢，它这个原料这一块啊，因为之前的聚乙醇酸呢，其实用到工业上的其实比较早，也是国外最早的，比如用到这个手术缝合线啊这块。但是国外的话，它始终的这个产量啊，它前面是日本和美国啊都帮，然后在美国那边建立工厂，基本上就在4000吨啊、8000吨啊这种，基本上都没到万级的这个规模。因为它的这个生产原料呢，我们看了一个是氯乙酸，一个是氢氰酸，基本上是这两种途径的，所以它本身的是一个就是环境不友好的一个原料的一个工艺。对吧？然后呢，它的那个，当然它用的成本呢，这方面肯定会比较高，所以它用到了这个比较高精的，用到手术缝合线这一块。所以呢，我们实际上呢，从煤机路线做到聚乙醇酸啊，这块应该来说，可能也只有在中国啊这块的这个煤化工这块的发展，应该来说投入的精力也比较大，成果也比较显著的这块来自然的发展起来的。因为这一块的话，所以讲呢，为什么说它跟绿色化工结合？一个首先我的原料，我的路线，首先我是绿色的，对吧？然后呢，在这个项目的发展过程中，它同样的，它第一步碳化做到超载加酯，它还是一样的，还是用到这个钯贵金属这一块。然后你随着这个聚乙醇酸技术的工业化推广，那自然的这个贵金属的钯的使用量也会增加的，对吧？当然，在这个整个工艺过程中，我们也会注意这个不断的工艺优化，实际上降低能耗各方面，包括还有这个尾气的这个处理，其实我们也是用贵金属催化剂来去把这个氮氧化物把它处理掉，这个是在整个工艺过程中。另外呢，还有就是刚才说到原料这个工艺，对吧？工艺其实结合催化剂这个过程中，还有这个产品本身聚乙醇酸本身，它是一个在海洋中，对吧？海洋中都可以降解的一个降解物质。因为现在的话，提到降解呢，材料呢，大家都比较热啊，但实际的工业化应用呢，确实是比较少。因为我们讲完全的绿色，对吧？从原料呢，你从植物啊或这样来，但确实呢，这块的它成本比较高，而且呢，也受到这个方面的这个限制。但是你对于这个大众来说，我要用到降解材料，跟我用塑料相比，你如果说成本贵个几倍，那这样的话，大众也没办法接受，对吧？所以说，如果像我们现在发展，比如说从煤机的，当然不一定煤机啊，是合成器，然后发展聚乙醇酸，我一个成本比较低，对吧？我又容易工业化放大，然后呢拿到的这个材料又是确实是一个绿色的，降解速度也比较快的，然后确实是能够降解的一个材料，那我觉得这块的发展前景还是比较好的，好吧？我就介绍这个。
好的啊，谢谢卢总。我们希望这个普景化工将来在这个领域做出更多亮眼的成绩啊，有更多亮眼的成果。最后一个问题呢，我们请教一下这个曲总。曲总呢，在这个贵金属啊，这个分析领域是资深的专家。刚才呢，您也给我们介绍了，就是贵金属在绿色化工，这个尤其是催化领域有不可替代的这个价值。从英美资源的这个角度，您建议 在未来绿色化工这个领域，哪些产品或者说哪些企业希望更多了来跟这个英美资源做合作
to collaborate in the green chemistry? What are the opportunities you are looking at?
Thank you for the question. Currently, green economy is a global trend, and green chemistry represents direction for the future. Actually, currently we've paying attention to the back carbon neutrality and carbon peak, how various industries can achieve the carbon neutrality of various industries. We have done such research, and like what was mentioned by the moderator, compared with other industries such as energy, electricity, and transportation industries, the chemical industry currently faces the biggest challenge because the industry is so huge with so many different types of products and different types of technology pathway. So given the status quo and given the situation as PGMs is the king of catalyst in the industrial application with high selectivity and high efficiency, how can we say that green chemistry still focuses on technological innovation and progress? And how can we be more innovative to find smaller, cheaper equipment or processes to replace the massive and expensive and high energy consuming equipment and processes? I think this is a topic that's of common interest, and PGMs in this process will represent a key part, as PGMs can make reaction more efficient and reduce the energy consumption during reaction and reduce the generation of reaction waste. In other words, it saves unnecessary, it reduces unnecessary waste, and it increases the yield of desired product while reducing the generation of byproduct, reducing harm to the environment. We noticed a lot of cases of using PGM in green chemistry, such as synthetic amino, as well as low temperature, low pressure reaction condition with using PGM to greatly reduce the energy consumption. And in dealing with the volatile organic compounds, and in cases where industrial wastewater that's hard to process needs to be dealt with, PGMs can play a role. So in all these areas, like the organic compounds and the industrial wastewater, the treatment of these things is in line with green chemistry. So I think we need to understand the trend of the industry, and we need to figure out the trends for the future. And in this process, we need to, well, as was mentioned before, that PGMs are indispensable. They play an indispensable role. So I think in all these areas, I'll say in these processes, Anglo America as a leading supplier of ore, we are willing to do our due share to the industry. Thank you. Thank you, Grace. You have just pointed out to us a very important way of moving forward. In other words, all challenges come with opportunities. As you know, environmental requirements and requirements on emissions and on consumption represent challenge to our industry. However, Grace just given us several different aspects. She actually reminded us that in addition to figuring out how to deal with the challenges, we need to find opportunities as well. Well, that echoes ancient Chinese culture: in all crises, born opportunities. Thank you very much. I will give you a short summary For the chemical industry, technology innovation is the driver for green development. That's the only way forward for our industry. In other words, we don't have any other choice. According to our alliance statistics, in 2022, the entire industry's turnover was 9.56 trillion RMB. And in 2020, China's chemical industry was already #1 globally in terms of the turnover. What does green development mean? It means that the chemical industry needs to slow down or even stop development. Definitely not. It means that the industry needs to seize opportunities to achieve faster, better, and higher quality development and growth. As you can also read from the 20th report by the National Congress of China, there is a sentence: new areas, new momentum, and new advantages. It means that in the face of all these challenges, we need to rely upon technological innovation as a key driver, and green chemistry will play a core role in industrial transformation and upgrading. A lot of experts mentioned this key sentence that the chemical industry is different from other industries in that only our industry has this special capability of dealing with things at the level of molecular structure. At the molecular level, we are capable of changing things at the molecular level. That's a unique advantage of our chemical industry. So we heard from experts several pathways. One is the technological innovation to replace toxic and hazardous substance in combination with industry guidance, catalog, and international conventions. We, as players in industry, we find new molecules or we invent new products, more environmentally friendly products and processes to replace the harmful and the hazardous products and processes. Second is to promote high efficiency and low emissions reaction processes, and to turn such high efficiency and low emission processes industrial scale. And so we also heard experts talking about reducing the emissions of pollutants, and the industry is also working on green products, green factory floors, green parks, and the green ecosystem. So I am confident that in the transition towards green chemistry, we will have a bright future. Thank you. Thank you. Many thanks to our panelists. Well, many thanks to all the panelists for the wonderful discussion, and special thanks to the moderator.